So here we'll check out part C, problem number 6 from 2010 AP exam. And we are asked to find the particular solution y equals f of x with initial condition f of 1 equals 2 to this differential equation. So if we're solving a differential equation, we're going to use the technique of separation of variables. And so what we can do right away here is we can divide both sides of the equation by y cubed. We can also multiply both sides by dx, and the variables are now separated. And to get rid of the differentials, we're going to do integrals on both sides, or antiderivatives on both sides. So we're going to integrate the left side with respect to the variable y, and we're going to integrate the right side with respect to the variable x. The antiderivative on the right side is pretty simple. We're going to add 1 to the exponent, and we're going to divide by the new one. I'm going to put a plus c on that side. On this other side, I can move this y across the fraction bar and into the numerator as long as I change the sign on its exponent. And now if I take the antiderivative of this by adding 1 to the exponent, dividing by the new exponent, I should technically be adding another c here, but I'm going to try to solve this for y in a minute because we want the particular solution y equals f of x. We want our answer solved for y. And if I put a plus c here, my first step in solving for y is going to move the c that I have to the left of the equal sign over with the one from the right. And it's going to still be some value that we don't know, some constant that we don't know the value of. So what typical notation is to just add the constant of integration on the side that includes the independent variable, which is, in this case, x. So we want to try to solve this for y. I'm going to get rid of this over negative 2 right away. I'm going to multiply both sides by negative 2. So if I multiply both sides by negative 2, I'm not going to have an over negative 2 on the left side of the equation anymore. And then on the right, I'm going to have negative 2 distributed into both pieces inside that set of parentheses. So the negative 2 here and the over 2 there are going to cancel with each other. And so the coefficient of x squared becomes a negative 1. Now technically when I distribute negative 2 into plus c, I get negative 2c. I don't know what c is. I don't know what negative 2c is. So to keep this as simple as it can be, let's just still leave it some arbitrary constant that we don't know the value of. Now on this side of the equation, if we're trying to solve for y, we're not going to want a negative exponent on it. So I'm going to move the y back across the fraction bar into the denominator, and it's going to look like this. Now we can go ahead and do one of two things. You're going to eventually have to use this condition, the fact that when x is 1, y is 2, to figure out what c is. This doesn't seem like a very difficult equation to attempt to solve for c. So you can either solve for c currently when the equation is not totally solved for y and then continue to go about solving for y, or you can solve for y, then put 1 in for x, 2 in for y. But if you go that route, you're typically going to have quite a bit of algebra to do again to solve for c. So what I'm actually going to do at this time is I'm going to apply this condition. And when I apply this condition, I know that the function value, or the y value, is 2. So that's going to be 1 over 2 squared, which would give me 4. So I get 1/4, and that's got to be equal to negative 1 times 1 squared, right? I'm putting 1 in for x plus c. Well, negative 1 times 1 squared is negative 1. So if I'm trying to solve for c, I'm going to add 1 to 1/4, and that's going to be 1/4 plus 4/4, which gives me 5/4 as my value for c. So what I know now is I know that 1 over y squared equals negative 1 x squared plus 5/4. Now I still don't know what y equals. It says to find the particular solution y equals some function of x. So we do still have to do a few more things to solve this entirely for y. We need to get the y out of the denominator if we're going to solve for it. So if you multiply both sides of the equation by y squared, you'd be looking at 1 equals everything that we have here. I'm going to write this with the 5/4 listed first, and then minus 1x squared, or minus x squared second. And then I'm multiplying that by y squared. If I'm trying to solve for y, I'm going to have to get all of this stuff over onto the other side. So I'm going to have 1 over 5/4 minus 1 minus x squared. And that's going to be equal to y squared. What's y? We'll take the square root of each side, and you end up with plus or minus square root of 1 over 5/4 minus 1x squared, or minus x squared. That's what y equals. This is kind of an ugly particular solution. We typically don't like to see a fraction within a fraction here, so there's some algebra that you could do, some arithmetic that you could do to clean that up and resolve that issue. I am going to do one other thing here. I don't really care for the plus or minus that's out in front of this. Now, I can't just drop it, but what I can do is I can look at my initial condition, which was f of 1 had to be equal to 2. This y value is positive, and so basically what that means is that the solution that we're concerned with is going to be the one that involves positive answers for y, or the positive root. So that basically allows me to eliminate the plus or minus and just go with the plus. And the square root of 1 in that numerator is 1. So just to clean it up and make it look a little bit nicer, we can rewrite it as no plus or minus anymore. We're taking the positive root rather than the negative because y is positive. And so we say y equals a positive value. It's 1 over square root of 5/4 minus x squared. So there is your particular solution.